Okay, welcome back to CAD Camp. Today we're going to do some sketching and jointing and making objects 3D. This will be most of what you're doing when CADing. So we're going to do a 12 by 10 plate for a theoretical shooter. And we want this to be symmetrical with some bearing holes. Put two bearing holes approximately there, and then some mounting holes over here. So for these bearing holes, we want these to be exactly 1.125 inches in diameter. And because both of these are bearing holes, we're just going to use the equal constraint and set them equal to each other. And then now that they're the exact same size, we can move them around, but we cannot increase the size. So we're going to define where they're supposed to be, and we're going to make it 1.25 inches from the edge and 1.25 inches from the other edge. And then we're actually going to separate these two circles by a distance of 1.25 and make this distance the same as the other, 1.25. So we have our two bearing holes exactly where we want them to, but we also need to know the diameter of this hole. Now this is going to be a 1032 hole that we want to go, or a number 10 hole for a 1032 screw that we want to go all the way through this plate. So what we're going to do here is check our drill and tap chart to find what size hole we want this to be. So if we have our tap and drill, or tap and clearances chart up, we can see the metrics are here, but we want an imperial screw. So we're going to go to the second page and take a look at this number 10 row. Now we want a free fit clearance drill hole, so we're going to use a 0.201 size hole. And we're going to dimension this 0.201 inches, and that's our diameter. And then we're going to make this 1/2 inch from the edge here and 1/2 inch from the edge here. Now what we can do is reflect all of this onto the other side of this piece. So if we use the mirror tool here, first we need to create the line that we're mirroring over, and we can make this a construction line because it's not actually going to be used to separate anything. So we use our mirror tool and select the objects we want to mirror, which will be these three. And then we're going to select our mirror line. So these objects will be reflected onto this side. But we don't want just one hole on this plate. We're going to want a whole bunch going up the length of this plate. We might not use all of them, so that will be decided later, but we're going to use a rectangular pattern to create a 1/2 inch pattern going up the length of this plate. So we're going to separate this distance by 0.5, and we're going to make this quantity 10. Or let's go to around this 7.5 inch mark, so let's try 15. Oh, that was the wrong direction. We want the 1/2 inch quantity to be 15. There we go. So this creates the grid that we want over here, and we somehow need to reflect this onto this other side. So let's try and figure out how we can do that. We can first try to attempt to edit this symmetry constraint and see if we can mirror the rectangular pattern. So let's select see if we have to select our objects individually, or if we cannot select that constraint. So we're going to see if we can select these, and then we're going to select this object, and now we have all of these holes over here. So this is kind of the general layout we want for this plate. And we're going to go ahead and finish this sketch out. So now we have a plate, but it's only in 2 dimensions, not 3. So what we're going to do is use our extrude tool, or our E key, and extrude this by 0.125 inches. So this is 1/8 of an inch thick, and is currently made out of steel, according to these properties. So if we go to our bodies, and we look at properties, you can see that this physical material is steel. The appearance is steel satin. It will give us a center of mass, a actual, where is the mass? Yeah, here's our mass, is 65.269 ounce masses. And it'll give us a density based on that material, and all these other calculations that we can use from what it's given us. What we would like to do is make sure that we are keeping these materials as close as possible to what we are actually using on the robot. So if we were to machine this plate, it would not be out of steel. It would be either out of aluminum or more commonly polycarb. So what we're going to do is go to our modify menu and select our physical material menu. And in here we're going to find a whole library of various materials. Let's see if I have this favorited. I do. So what I have here is a list of favorited materials. In here is polycarbonate clear. If you are not have this favorited, this is probably going to be found in our plastics. If we scroll through these, we will find polycarbonate clear. And so if we drag and drop that over our piece, we will see that it takes this kind of clearer appearance. Only the edges are highlighted and we can kind of see through it. And if we close that off, we will now right-click this body again and look at properties. And this object now has the properties of a polycarbonate plate, which is 9 ounce masses. Now, these are really important when we're doing center of gravity calculations for our robot. So if we're hanging, or if we're trying to make sure we're under the weight limit, all of these, doing this for all of our parts is very important. So, for example, if we go to our inspect feature and display the center of mass of this piece, it's going to calculate exactly where that would, or it'll crash. It'll calculate exactly where that's going to be, and you can see it's kind of in the middle of this plate. If we go to analysis, open that drop down, we can see where this exactly is. Now, it's 5 inches in the X direction, to the right, so along this line, 5 inches across, which is exactly the center of our plate, which is because the plate's 10 inches. But if we look at the Y direction, it is 5.874 inches to the right in this direction, despite this being 12 inches. And that's because we've taken off more material on this side. So it's shifted the center of gravity closer to this side.